A part of your design process is evaluating your solution and making any recommendations. And in this case, part of the evaluation will be how much money it costs. And there's a guide in your chapter module that kind of helps guide you through that. And so this is how we figure out our cost. Your design cost, which is the labor, how much you're paying yourself to design the object, you're being paid $30 an hour, so that's part of how much it costs to make the charm, to make one prototype. The material that we're using is Eco ABS. You can see in your chapter, they're giving you a price for Eco ABS of $35 per half kilogram of filament. But being a smart shopper, I know it's on Amazon, same price for 0.75 kilograms. So I'll take the cheaper price. And since we are dealing with little small charms, kilograms is going to be a lot larger unit than what we'll probably work with. So we're going to convert that to grams so we have a more realistic idea of how much it costs. So $35 per 0.75 kilograms, and I convert kilograms to grams. Grams cancels, or kilograms cancels. I'm left with grams. So 35 divided by 0.75 divided by 1,000, it's 3 cents per gram of filament that I use to make this. And as a note, the density of Eco ABS is 1.24 grams per cubic centimeter. So that is mass density right there. Okay. My printing cost is 80 cents an hour. So that's how much it costs for me to operate the printer, the cost of buying and maintaining a 3D printer. So to calculate total cost, I'm going to add up all of these quantities. And right now, this is an estimate. You know your design time, so $30 an hour times the amount of hours you have spent working on the design, the cost of filament times the density times the volume of your model. Because we have grams are going to cancel grams, cubic centimeters are going to cancel cubic centimeters, and this amount, the volume of your model, is determined from Fusion. And you will have that in cubic millimeters, so you'll have to make a conversion here to cubic centimeters, okay? Plus how long it takes to print it. So let's say an average print time for small charms is 2 hours. So $30 an hour times your amount of time spent, the cost of filament times the density times the volume of your model, plus the number of hours it takes to print the model times the rate per hour. So you add these three up, and that's the cost estimate of your model. Now, this is an estimate because if we look at this 3D slicing program, this is a program that takes your model and prepares it for 3D printing. Now, the volume of your model is going to be different when you actually print it because we're not printing a solid piece of plastic. You have some options in your slicing program of what quality resolution you want to print at, okay? And then you also have options for infill. If you change it to 100%, that makes a solid object all the way through. But that's not necessary. We don't want to use that much material. We can change it to 50% or 20% depending on the strength requirements of your model, and that saves material. So if I choose those settings and hit prepare, I now have the exact, or not the exact, but the estimated print time of 21 minutes, and I have a pretty close estimate to the amount of plastic that's going to be printed, about 3 grams. So now I can turn that estimate into an actual cost once I have printed it. So first, do your cost estimate. Then after you have printed, our actual cost, your amount of labor should stay the same, but this is what changes right here. We're going to have cost of the filament, 3 cents per gram, times the amount of grams that we can determine from the slicing program. And additionally, after we print it, we can also just put it on a scale and measure the amount of grams. But 3 cents per gram times the amount of actual printed material times the actual print time, this will be your actual cost. Okay? So we want to do your estimated costs, and then if you get your model to me and we print it, we can determine your actual costs. That will be part of your portfolio.